Have you ever looked up at the night sky and wondered if we are alone in the universe? As vast and infinite as it appears, it's only natural to ponder upon the existence of life beyond our home planet. This very curiosity has led to some of the most fascinating discoveries in the field of astronomy. Among these are exoplanets, celestial bodies orbiting stars outside our solar system. But what makes these discoveries even more tantalizing is the possibility of these distant worlds being habitable. Imagine a planet light years away, with conditions suitable for sustaining life as we know it. This isn't mere speculation, but a reality NASA, the world's leading space agency, is actively exploring. Through a meticulous process of observation, identification, and characterization, NASA scientists have been uncovering these potentially habitable exoplanets, each one a beacon of hope in our quest for cosmic companionship. This brings us to the intriguing process of how NASA discovers these potentially habitable worlds. The first step in this cosmic quest involves keen observation and meticulous data collection. Picture a distant star in the vast expanse of the cosmos. Suddenly, there's a tiny dimming of light, a fleeting eclipse caused by a passing celestial body. This is the transit method in action, a subtle game of cosmic shadow play that hints at the presence of exoplanets orbiting distant stars. And who's the detective in this interstellar mystery? The Kepler Space Telescope, a diligent sentinel tirelessly scanning the heavens, capturing these minute drops in stellar brightness. But the Kepler doesn't stand alone. A plethora of space telescopes, each with their unique abilities, patrol the cosmic ocean, gathering invaluable data. There are eyes in the sky, revealing the hidden gems of the universe. Their mission: to detect potential exoplanets, those mysterious worlds beyond our solar system. With data in hand, it's time for identification. Armed with the observations, scientists now embark on the task of identifying potential exoplanet candidates. Like detectives on a cosmic crime scene, they meticulously analyze the collected data, focusing on the intriguing phenomenon known as light curves. Light curves are fascinating graphs that illustrate how the brightness of a star subtly changes over time. Imagine stargazing on a clear night and noticing a star's light dimming ever so slightly. That's essentially what scientists are looking for, but on a much grander cosmic scale. These minute dips in brightness can be the telltale signs of an exoplanet crossing in front of its host star, much like a cosmic game of hide and seek. Through careful analysis of these light curves, potential exoplanet candidates are identified. Each one is a potential new world, a possible home away from home. After identifying potential candidates, the next step is characterization. Characterization is the process of getting to know these far-off worlds a little better. Once potential exoplanet candidates have been identified, the real detective work begins. Scientists turn to a host of space observatories, armed with a variety of instruments, to gather more data about these distant objects. The size of an exoplanet, for example, is typically inferred from the amount of light it blocks when it transits, or passes in front of, its host star. Mass, on the other hand, is a bit trickier to measure. Often, it's determined indirectly through the gravitational tug the planet exerts on its star. The orbital period, that's how long it takes for the exoplanet to complete a single orbit around its star, can be deduced from how frequently we observe the transit events to occur. And from this, we can even calculate the distance the exoplanet is from its host star. With a better understanding of the exoplanet, we can now assess its habitability. The habitability assessment is where the real excitement begins. This phase is like the grand unveiling of a mysterious new world, where scientists determine if an exoplanet falls within the so-called habitable zone. Picture this zone as a Goldilocks region around a star, not too hot and not too cold, but just right for conditions that could allow liquid water to pool on a planet's surface. And why is water so important, you may ask? Well, as far as we know, water is the lifeblood of biology, a fundamental ingredient for life as we understand it. Yet, it's essential to remember that this assessment is not a confirmation of life, but rather, it's an assessment of potential, a whisper of possibility in the vast cosmic orchestra. But finding water is just the beginning. There's more to habitability than just that. The presence of liquid water alone does not guarantee life. There's more to it. The potential for life extends beyond the mere existence of liquid water. It's a cosmic dance, a balancing act of many factors working in harmony. Consider the planet's atmosphere. Just like a blanket around us on a winter's night, an atmosphere can keep a planet warm. It can maintain a stable temperature crucial for life as we know it. But not just any atmosphere will do. It needs to be just right. Too thin, and the planet becomes a frigid wasteland. Too thick, and it turns into a pressure cooker. Next, let's look at the planet's geology. Active geological processes can recycle essential nutrients, making them available for potential life forms. Think about the stability of the planet over time. Life needs time to evolve, to adapt. Constant drastic changes can wipe out any chance of life before it even gets a chance. And thus, the quest for life beyond our planet continues. The discovery of a potentially habitable exoplanet is just the beginning of a much longer journey. Once these celestial bodies of interest are identified, the real work begins. Scientists roll up their sleeves, delving deeper into the mysteries that these exoplanets hold. Using advanced telescopes and state-of-the-art instruments, they scrutinize every detail, every clue that could hint at the existence of life beyond our blue planet. Take, for instance, the James Webb Space Telescope, a marvel of modern technology. This behemoth of a telescope, which is set to launch in the near future, is expected to provide unprecedented insights into the atmospheres and compositions of exoplanets. It's these types of missions that keep the flame of exploration burning bright, fueling our curiosity and our desire to understand the universe we live in. In the quest to answer the question, are we alone? Every discovery brings us one step closer to the truth.